We look at decision tables in object-oriented systems analysis and design. Being a systems analyst is all about analyzing potential projects or system projects. So if you have projects that are supposed to be accomplished, software engineering projects. Let's say maybe there's a proposal for a website for a school or a hospital. Your job as a systems analyst is to check if that project is, if it is something that is profitable, if it's something that is profitable, number one, and then number two, you check what will be required for that project to be accomplished. Okay, what is needed for that project to be put together? What is needed for that project, to be an actual working system? So there's so many tools that we use when we're doing this. So um, one of them is the decision table. So a decision table is something that is very, very important in as far as systems analysis is concerned. So as a decision table, what is a decision table all about? So a decision table is a type of table that shows the relationship between inputs and rules of a system. What does this mean? It's a type of software testing tool. Okay, you basically use it to test tools. Okay, to test software projects. Okay, let's say maybe you've got software that you're designing, an application that you're making. You will basically use a decision table to how a system is going to respond to different types of input. When a system is fed this type of input, how is it going to react? Okay, what type of output is it going to give you? So that is what decision tables are all about. So it basically analyzes how a system responds to different types of inputs, okay, to different types of input. That is what a decision table does. So it basically analyzes um, how a system responds to different types of input. This is what it does, the decision table. So you basically manufacture or you construct a decision table in order to check how your proposed system is going to um, respond to the different types of inputs that you are going to supply it with. That is what a decision table is all about. So, like in this case, when you check question number two there, you've been asked to create a decision table to simulate a login screen. To simulate a login screen. And the condition is that the user will be routed to the dashboard screen if they provide the correct username and password. If not, the system will show an error. Usually, when you're logging into different platforms, you're supposed to type the correct username and you're also supposed to type the correct password. That's when you'll be able to log in successfully. But if you do not, you will encounter a problem in that you will not be able to log in. If either your username is wrong or your password is wrong, you will not be able to log in successfully. So that is an example of how a decision table works because you're providing those types of inputs. So it is one way of testing if the system is going to work correctly, because you're providing it with different types of inputs that are true and inputs that are false. Then you see how the system reacts to that. So with that said, uh, let us um, let us construct uh, let us construct the decision table that we are required to construct now. Let us construct that decision table. So we need to create a decision table. We need to create a decision table. So what we need to take into consideration is how many inputs are we gathering here. So you can see there the inputs that we are gathering are two. We are basically obtaining the username and we're also obtaining the password. Okay? So we've got two inputs. So what you're supposed to do is you're supposed to use this formula where you say 2 to the power number of inputs. Okay, 2 to the power number of inputs. Okay, 2 to the power number of inputs. This is the formula that you're supposed to use. This formula is used to determine just um, how many rows your table is going to have, or how many columns in this case, how many columns your table is supposed to have. Okay, so 2 to the power number of inputs. So we are saying 2 to the power 2. So what is 2 to the power 2? Since we've got two inputs, 2 to the power 2, the answer is 4. Okay, so that means our table is going to have 4 inputs. Let us construct that table now. Let us construct that table. So the way the table is going to be arranged, it will be arranged as follows. Okay. Okay. So in this part, first, we're going to have the conditions. Okay. We're going to have the conditions. Okay. And which ones are the conditions? The conditions are the username and the password, right? These same conditions can also be referred to as inputs. They can also be referred to as inputs. Okay. Then here we're going to have the rules. Okay. The rules. So we'll have row 1. Then here we'll have row 2, row 3, and row 4. Okay. So you can see these 4 rows. It is this formula here, 2 to the power 4, that is actually determining this. It is this formula, 2 to the power 4, that is determining this number of rows. Okay. And then the next thing that we should have here, we should have the output. Okay. The output. Okay. The output. Okay. So the rules are quite simple. The rules are quite simple. So we are going to make uh, different rule combinations. Okay, we're going to make different rule combinations. Okay, so these rules are basically saying if the username is false or if it is true. So these rules are going to be combinations of F and T. F for false. So F is false. F is false. And then T is true. Okay, so we will combine them until the combinations have been exhausted. Okay, so let us start with when the username is false and when the password is false. So according to the question, the condition is that the user will be routed to the dashboard if they provide the correct username and password. So like in this case, okay, so the correct username and password will mean the system will will show the dashboard screen, okay? But if the username and password are not correct, if not, the system will show an error, okay? So like in this case, the username is false and the password is false. So the output there is going to show an error, okay? Next, we are going to say if the username is true and the password is true. So here, if it is all true, we've been told that the system is supposed to route to the dashboard. What if the username is true but the password is false? Even here, you're going to see an error because both things are supposed to be correct. Both things are supposed to be correct. And then here, let's make the final combination. So it's just about ensuring that all the combinations have been satisfied. Okay? Because from here onwards, there are no more combinations. So even that is going to show an error because we've been told that the system should strictly route to the dashboard if the username and the password is correct. So this is what a decision table is all about. It is just basically testing how a given system or a given application reacts to different input conditions. So that wraps up the first question. Now let us turn our attention to the second part now. So the second part there, we've been told that we need to create um, a decision table to simulate the working of a bar. If a system is, if a customer is 18 and above, they are allowed entry. If not, entry is denied. Okay, entry is denied. So bars they operate on the constraints that uh, the whoever visits the premises has to be 18 and above. There's an age restriction there. There's an age limit. Okay, there's an age limit. So let us design that particular uh, condition. Okay, let's design the decision table now. So mm we will follow the same 2 to the power number of inputs. Okay, 2 to the power number of inputs. Okay, so how many inputs are we having here? Okay, how many inputs are we having here? So here the number of inputs that we're having is just one because we are looking for the customer's age. Okay, we're just looking for the customer's age. So the input here is just one. Okay, so since the input is just one, we shall say 2 to the power number of inputs, okay, which is 1. So 2 to the power 1 is simply 2. That simply means that we'll just have two rows. So we'll just have row 1 and we'll have row 2. Okay, we'll just have row 1 and row 2. Then here we'll have our inputs, of course. And then here, what is our input? Our input is age. Age is our input. Then here we're going to have our output, of course. So rule 1, we're saying that if the age is greater or equals to 18. So if age is greater or equals to 18, okay, so if age is greater or equals to 18, what is the output? You're supposed to allow entry, okay? You are supposed to allow entry. If the age is greater or equals to 18, you're supposed to allow entry. Okay, and then here, if the age is less than 18, okay, so if the age is less than 18, if the age is less than 18, then here you're supposed to deny the entry. You're supposed to deny entry. So this is how you are supposed to design this second decision table. So decision tables are very simple software testing tools that will basically just gather inputs, and then those inputs are tested to achieve uh, the objective of ensuring the system is working correctly. This wraps up this lesson. In the next lesson, we shall begin now looking at use case diagrams. Thank you for watching.